In the last section, we talked about different types of data, and we saw that there were variables that were either going to be qualitative or quantitative. That was, we were either going to have variables that asked for some sort of like word response or a numerical response. And in the following sections of Chapter 2, the remainder of Chapter 2, we're going to be specifically focusing on quantitative variables, that is, data sets that end up being numerical. So as a possible example, you can take a look here at the following bar graph that comes from the U.S. Census Bureau report on household incomes. So obviously if I asked a household how much money do you make in a year, they're going to report back to me with some sort of a numerical value. Now we can put those pieces of information here into this kind of a bar graph. It may be a little bit difficult to go ahead and actually see these numbers down at the bottom, but if you have the actual file open yourself, you might be able to zoom in and see what's in there. So once we have a bar graph or a histogram actually down on the page, there are three ways that we are going to be interested in trying to describe a data set. Now, in this section, our main focus is actually going to be here on this first approach, which is a measure of center. So when we talk about a measure of center for a data set, what we're really attempting to kind of ask ourselves is, what does a typical data value look like, right? We're kind of wanting to know what is a typical data value for this data set. What would almost be like a representative data value. And that's going to be the focus of this section. You'll see that actually if I skip down to number 3, we can also describe a data set based on its shape, which we talked about in the last section, right? We saw that we could describe data sets as skewed or symmetrical or maybe uniform, and we could ask a lot of other questions as well, like where is the data ultimately kind of like largely grouped, right? We could say, are there more high or low values in the data set as a whole, right? These are some questions that we could ask. We could ask, are they evenly spread out, right? That is, like, is the data kind of evenly spread across, all the different possible values? So when we talk about shape, we're kind of asking questions like that. And that's how we come across these descriptions of uniform distributions or skewed left, skewed right, or symmetrical. Well, in the next section, we're also going to talk about the ideas of measures of spread, that we can ultimately talk about how spread out a data set is. And ultimately, we would really be asking ourselves the following question there. We might ask a question like, how far away from typical is typical? Now this is kind of a strange sentence, but you can often think about it in the following way. A lot of times if you want to know, maybe say on an exam, what is pretty standard or typical for performance on an exam, you'll oftentimes ask an instructor for something like, what was the exam average? And when the instructor maybe gives you what that exam average is, say, well, the average is 78% on this exam, typically, then what that is going to not really tell you is, well, not everybody probably gets exactly 78, so how far away from 78, how far away from that typical 78% value is still pretty standard or still pretty typical to see? So what measure of spread is going to give us is some sort of like a window of what's typical. So again, we'll talk more about measures of spread in the next section. Our goal here in this section is to talk about measures of center. And I've already kind of alluded to one of the possible ways that we can measure what a typical value or typical data value looks like. Now down here, I list in the box our kind of definition of measures of central tendency. Again, it's a value that's going to represent a typical, central, or representative entry of a data set. And there are going to be 3 commonly used measures of central tendency, and for most of us this is no surprise. We have values like a mean, a median, and a mode. Yeah, we're in a stats class. We're talking about mean, median, and mode again. You've probably seen these terms and dealt with them ad nauseum in the past. I'm going to quickly go ahead and just work through some calculations with these momentarily in example number 1, just to make sure that we all understand, as a quick recap, what each of these things are and how I would find them. All right, so let's take a look down here at example number 1 rather quickly. I want to find the mean, median, and mode for each of the following data sets. Now, each of these apparently are data sets that recorded a time it took for students to complete a quiz in my 8 a.m. class and in a 10 a.m. class in a previous semester. Well, let's start by going ahead and calculating the mean. You might recall that another name for the mean would be the average, right? They're the exact same thing. They're just synonyms of each other. So when we say that we're going to calculate the mean or the average, we know that we should be taking all of our different values and adding them all together, and then of course dividing by however many values that we had. So in this case, I would divide by 5. Now if you were to go ahead and actually simplify this all the way down, I think here we end up with a value of 14.4. Now, every time in our class when we calculate something like a mean, median, or mode, or really almost any other value, we're going to want to put units on this number. So when this says 14.4, I want to know, like, 14.4 what? Is that 14.4 books? Is that $14.4? What are we talking about here? But obviously, if this is time it took to complete a quiz, I might be able to say that this is 14.4 minutes. Notice on the other side, I can do the exact same thing. So my mean, same thing as my average. Notice here, this is actually going to be super simple to calculate. I think grand total here, I'm going to have 40 on top, divide by 4. That should just give me 10 minutes. Okay, so it's not difficult to see here how exactly I'm going ahead and computing an average. Now, medians can sometimes be a little bit different. They can have some complexity depending on how often you've dealt with medians in the past. Remember that a median is often thought of as the central value or the center value, the middle value of a data set after you've lined the data set up and you started to kind of figure out, again, from lowest to highest, which number ends up in the middle. So here, I notice I have that data set listed out in increasing order, and so I can easily see here that the number 15 is smack dab in the middle. So 15, I'll put units on there, 15 minutes would be my mean, or my median. Now this obviously becomes a little bit tougher on the other side when, well, I don't really have a middle value, right? Because there's an even number of items in this data set, there is no middle. I mean, technically the middle falls right here, but there's no number there. So what we often do in this case is we're going to be taking the average of these kind of almost middle terms. So the ones that are right there next to that middle on either side of that dashed line, I'm going to go ahead and add those up and divide by 2, which in this case is still going to get me that value of 10. Okay, great. Mode, that's the last value that we have here. Mode is always going to be the number in the data set that occurs the most frequently. So in the first data set here, you'll see that 15 occurs the most frequently. So I'm going to have 15 minutes. And over here, what I'll see is that I ultimately have, I guess, kind of a tie for which number appears most frequently. So I would actually, in this case, go ahead and write out both of these values. They both end up as the mode. And I would refer to my data set as bimodal. That is, it has 2 modes. And that's totally fine. You can have a data set with 3 modes or 6 modes or 1,000 modes. It doesn't really matter. It's just what number occurs most frequently. The only stipulation is that we always require that in order for a number to be a potential candidate for the mode, it has to occur at least 2 times. It's got to occur 2 or more times. So I would never allow 20 to be the mode if it only occurred once, even if it was tied with everything else. So hopefully this gives you a quick refresher on what mean, median, and mode are. And what we'll see in the next couple of videos is how we can decide which of these 3 measures of central tendency is maybe better to use in certain situations.